Okay, now we're going to discuss some people have been asking some questions, and we're going to talk about why the La Nina didn't happen the way it was supposed to. We're going to talk about why the California has been inundated with rain, how it affects the weather in Pennsylvania and New Jersey along the coast, and what it may mean for the hurricane season. But as you can see right here, this is the Tonga um, volcano in video when it went off, and it usually volcanoes will throw dirt and ash and everything into the air, and it will ref- cause cooling in the atmosphere worldwide when it goes off. But this one didn't do that. This one was mostly, you know, water. The water vapor that this kicked into the air was 10% of the total water vapor around the Earth was ejected into the atmosphere, and higher amounts of vapor into the air um, make will reflect and create more heat. So therefore, this actually heated the atmosphere than made the atmosphere cooler. So this was different than a lot of the different volcanoes. Like when Krakatoa went off, Mount Pinatubo went off, they ejected dirt and ash and all kinds of stuff in the atmosphere. This one was basically a giant seismic wave of moisture. Now, this year, most meteorologists were talking about more snow on the East Coast. I was one of them. We thought we'd get colder temperatures, and we had three strat warming events, which is quite unusual, which should have created three significant cold events across the eastern part of the United States. Well, we're going to have one next week, but it's just too late for it to be that strategic to create snowstorms. And we literally had a little one around Christmas time. If you remember, the temperatures were really cold. We had some snow in the middle of January, but these things were short-lived. They didn't really catch on. And part of the problem is it wasn't really La Nina. If you go back and listen to what I was talking about back in December, I said this really is not a La Nina. Anybody calling it that doesn't really know what they're talking about because things were just not in the right place. Another part of the reasoning was part of it was still the side effects from the Tonga volcano. To keep that in mind, and again, just one more note about that. That thing was just that the volcano erupted at the right depth in the ocean to do that. Any lower and it wouldn't have popped into the atmosphere as high, and it wouldn't have had as much effect. Any higher, it would have been even more. So it was at the right spot for it to hit. And unfortunately, it did. But these are fissures. This is a picture of a fissure. These are under the ocean floor. There's millions of these around the earth. And part of what we don't know, and the reasoning for mistakenly figuring out the weather sometimes, is when there's underwater uh, fissures like this erupt, or you get a volcano underwater with magma that you don't see, and you can only pick up seismic activity, and then therefore you can't really tell that the ocean's being superheated in some areas until it actually happens. You don't know in advance. Now here's Australia, and here's New Zealand, and here it was you can see right in here, especially this gray area here, this was a superheated water, which was not part of the forecast. This changes how water vapor goes and how strong the temperatures create air pressures and changes of atmospheric winds. Now, this was areas that seismic activity was detected, and you follow along this gray line here, and you can tell pretty much where these things are like in a straight line here. They were just either side of this line as they went up, and I'll show you why. Knowing that is important. This was a change in temperatures, and here's your gray line, and here's the ocean water being heated. And this was the period between middle of December and the middle of January of this year. So you know something was going on here. Unfortunately, there's no buoys that go down that far, and it can only measure the water temperature, say to around, I think it's 6,000 feet that I read, and it doesn't go down to the bottom, and you can see When you watch, you can see temperatures at the underneath the surface were warm, and then eventually they start to cool and they raise to the surface, and that's what's happening now. And then it's going to affect uh, big time what's going to happen. We're going to have one of the largest changes in water temperature along the equator, from very above normal to very below normal, and that is going to affect what's going to happen in hurricane season. Now, if you look over here, this is back in January. It was just starting to warm up over here by Eastern Africa, which is, and you can see a lot of colder temperatures out here too. Now we're going to go from this, and this is what we had this winter, but you could see the warm temperatures off in New Zealand from under seismic activity. You could see northern Pacific was warm. So what was happening is every time you had a strat warm, the water was just too warm in the northern Pacific, and all this churning out here just sent in Pacific air underneath the cold air, and therefore it did not allow a lot of these cold masses to come down from Canada and cool. And then therefore, if you look off the east coast here, the water temperatures were cooler because there were storms, but they were off the coast and they churn up the ocean and they make the ocean colder. So therefore, we lacked what we needed there to get it going. And this being up here should have been cold, and then that would have been a La Nina. But when this is warm and that's warm, it's not a La Nina, no matter what anybody says. It's not. It would be have to be cold, it would have to be blue up here and not the orange. Now, in contrast, this is where we're headed this summer, and then you can see 100 degree, 100 or 180-degree difference there. It's cold, not that warm temperatures. We still have warm air to the north and to the south of this, and you can see the Atlantic, where Africa is right here. Your lows come off here. They form these tropical storms and hurricanes, and then they head up anywhere in this area, and I would say anywhere from Long Island down through Florida and then around the Gulf, need to be weary of hurricanes this year and tropical storms, because I think they'll be above average in both categories this summer. And part of that reasoning is you're still going to have this warm air, so I think it's going to be cool until sometime in May. I mean, we're not going to have like summer come early, and we're going to actually have spring come later because we're going to go below normal for a few weeks. But it's not really going to turn into summer. But once summer comes around, it's going to be warm, and there's going to be these strong rainstorms that come up from the south ahead of the front, and we get these deluge of storms. What that affects Pennsylvania tornado wise, it's above average this year than normal. So we'll keep an eye on that. And that'll be part of the spring forecast that I'll have out around the beginning of April. So if you got anything to blame for your non-snow events or below average snow events that you won't, and just remember, Philadelphia in the I-95 corridor last year literally got zero. I think Philadelphia measured out at 0.2 inches. Point two, not 1 inch, but point two. And this year they had a lot more than that. They had probably, I think, 12 inches or something like that. So for them it was a little bit better, but still it was below average. It averages 20, around 20. I predicted 20 to 24. And the reason is we just didn't get that one nor'easter. So that was part of it. But if you're going to blame anything, you're going to blame the Pacific for being too warm. Here's the warm air over here in the Indian Ocean off of Africa. So you could see things just didn't line up, and therefore the La Nina forecast that everybody was coming up with just didn't happen. I thought we'd still get some of this cold air down and we'd get at least one or two coastal storms, but it just didn't happen. So not much you can do. And now that I've said that, I think the chances are big snows are done. There's maybe one towards the end of the month that has a possibility. And now that I've said that I don't think much is going to happen, I'm sure I'll look out my window and see a photograph like this one of these days before before April's over with. That's just the way it works. You give up and then you get hit. So, hey, you never know. All right, that was your educational video to teach you or show you why things didn't happen this winter. And I, for one, fell for some of the forecast models, and it just didn't happen. blame it on the Pacific. All right, take it easy.